So in this video, I'm going to talk about the half-life graphing. So in this graphing, first of all, you have to understand one thing is not necessary the first number here is the half-life, okay? Because it depending on did you divide the initial amount into half, okay? If sometimes the question did not give the grid, and then you don't always assume that the first grid is half-life. You have to say, oh, is it 600 divided by 2, 300? Okay, if that is half, then this will be the half-life. Okay, so if this 600 is not divided by 2 is 300. For example, if this number is 500, then the 60 will not be half-life. You have to see if this 600 divided by 2 to get 300. If yes, then the day, how many days it take will be half-life. Okay? So you have to be careful with that. Now, first of all, how do I analyze this graph is this amount here, the y-axis, this is remaining. How much gram remaining? Okay, how much mass? And then the x-axis would be the time. Okay, so first of all, what is the half-life? Again, you don't always assume that because this is the first grid and that's why this half-life. You have to see the original amount of 600 is it divided by 2 to get 300, and then how much time it take for the 600 for the initial amount to get half. If that's the initial amount divided by into 2, then this day is half-life. Okay? So you can see that, okay, because 600 divided by 2, I get 300. Oh, so this is a half. Then how much time it takes for 600 to divide it into 2 is 60 days. So in this case, this will be half-life. Another way you can see again is, oh, did I take 300 divided by 2, I get 350. Okay, so from 300 to 150, I also take 60 days. From 60 to 120, also take 60 days. Then in this case, you can say that the half-life is 60. Don't always assume that the first grid, okay, or the first point is half amount. You have to read the question carefully. Is this the first amount divided by 2 from the initial? So in this case, my half-life is 60 days. Okay, why is 60 days? Because it takes my original amount to be half. This days is 60 days. Okay, again, don't always assume that the first number here is half amount. Okay, sometimes the graph will trick you. Okay, and how many half-lives shown here? Now, because from 600 to 300 is half, so this is one half-life. From 300 to 150 is half, second half-life. From 150 to 75 is also half, 3 half-life. Now you can see that they are divided by 2, divided by 2, divided by 2. So you can actually count. Okay, now again, it must be, you have to investigate, is this from here to here is half? Because sometimes the curve gives you so many points. Not necessarily all the points are by half, by half, by half. You have to read the graph really carefully. So now here I can count that I have 9 half-life. I have 9 half-life. Now, what is the AO? AO meaning the initial amount, the original amount. So that means will be the starting original amount, which is 600 grams. And what is AT when the T is 180 days? So that means you're actually looking for A180. So what is the amount at the time is 180? Okay, so when the time is 180, the amount is 75. Okay? So when the day is 180, the amount is 75. Okay, when the time is 180, the amount is 75 grams. I'm going to actually make that to be green color. Okay. And what is the AT when the T is 240? So actually you're looking for the amount at the time 240 days, then what is the amount? So at the time 240 days, the amount is 37.5 gram. Okay. Now we have a few we have a few things we can talk about. Okay, so first of all, I have the triangle. This is a triangle. The AT on the top, A0 on the bottom, and 1/2 to the end. We have this all the time. And second is, what is the percent amount? Now, the percent remaining have two equation. One is AT over A0 times 100%. That's one formula. Or it can also equal to 1/2 to the power n times 100%. So either formula is remaining. Now, if I want to calculate the amount of decay, the percent, okay? How much remaining means how much left over. How much decay meaning how much gone. So how do you find how much is gone? So let's say, for example, you start with $10. You have $2 remaining. Then how much money gone? Oh, $8. How do you get that? You take your original number, original money, minus how much money remain. How much money left over will be how much money gone. So the same thing is here. You have calculate your percent remaining. Right? Now I want to find out how much is gone. So original number will be A0, but because we're using percentage, we can't use A0 because A0 is like gram. We have to use original amount. Original amount will be 100%. So we take original 100% minus how much remain percent, then will be the percent decay. Okay. And we know how to find the A0 and AT. We can get it from the graph. Okay, A0 and AT are on the graph. Okay, they are on the graph. Then what about the A decay? Okay, now how much originally is on the graph? How much AT is whenever the T number is, the T is 240, then my AT is 37.5. Oh, if my T is 360, then my AT will be 9.4 gram. Right? This is how much amount remain. They can both the AO and AT can be found on the graph. Then what about how much is gone? How much is gone? You have to take original 600 gram minus how much left over, which is AT. Then will be how much decay, how much gone. So in order for you to find the how much decay, will be original amount minus how much remain. Okay, so you have to do calculation here. Okay. So now let's read the question. If 3 half-life have passed, how many grams of iodine 125? Oh, first of all, I need to change the question. So decay, I have to change that to be remain. Okay. Remain, I have to change that to be decay. I'm going to change that all for 6, 7, and 8 question. Okay. Remain, change it to decay. Decay, change it to remain. So this will be decay. So we do that for 6, 7, and 8, and then we skip 9 and 10. Okay. Skip 9 and 10. Now, if half-life is 3, then how many iodine has been remained? So if you look it up, when half-life is 3, 1, 2, 3, then what is the time? The time is 180. Then what is the amount? Is 75 grams. So we're going to write, we can read it from the graph. When n is 3, okay, we can tell the amount at the time when, see, the time with 3 half-life, and the time is 180. So T is 180. When the time is 180, what is the amount? The amount is 75 grams. Okay. Now, how many grams of our the 125 have decayed? So we start with AO is 600 grams with A0, and my AT, this is actually, you can tell that this is my AT. Okay, you can tell this is actually my AT. Just like my T, but my T is 180. Okay, this is my AT. This is my AT. Okay, this is my AT. Just like my T is 180. Now, if I have my original amount is 600 grams and 75 grams has been remained, 75 grams have left over, then how many grams have been gone? How many grams are decayed? So we're gonna use this. It's just really simple algebra. Oh, I start with $600. I have $75 left over. Then how much money I have used up? We're gonna use this formula. Okay, so how much decay? Okay, how much decay will be A0 minus A180. Okay, I start with 600 grams, and this is like 75 grams left over. Then how much is gone? So 600 grams, that's what I start with, and my A180 is 75 grams, and I will get 525 grams. Okay. Now, what percent iodine 125 remain if half-life have passed? Now, sometimes we don't need to do the math on the part A, because part A, we can actually just deduce from that part of it. Okay. Now, when half-life is N, when half-life is actually, half-life is N, I'm going to do black pen because I have to do math here. Okay, now in my before another worksheet, I asked you to find out the gram, how much gram at the half-life N is 5. Actually, I don't even need to do that, because if I tell you that my half-life is N, how much percent remaining, we can actually, I don't even need to look up the AT, because I can actually use it 1/2 n to the power 1/2 to the power n times 100%. I don't even need to find the AT, but I show you both methods. So this method is the method I showed in class is if I find out the n is 5, then my time 300 days, my amount will be 18.78 grams. And then how much percent remain, I'm going to use this formula, AT over AO times 100%. My AT is 18.78, and my AO is 600, and then I times 100, I got 3.13. So this is one way that I show you in class, okay? But another way, quicker way is I don't even need to find the AT. Okay, I don't even need to find 18.78 because I can actually use the n here, since the fact that I have another formula. Percent remaining equals 1/2 to the power n. I can actually use it. Okay, so percent remaining. So instead of using AT over AO, okay, instead of using this formula, I'm going to use this formula. So 1/2 to the power n times 100%. And let's see. Oh, some people actually may want to make that to be 0.5. Okay, that's fine. Make it 0.5. Okay, if you want, make it 0.5. And my n is 5. And times 100%. If you do that, let's see. I'm gonna take out the calculator. Okay, I'm going to take out the calculator. Okay, so I'm going to punch in 0.5 times 0.5 times 0.5. Okay, and then times 100%. So 0.5 times 0.5 times 0.5 times 0.5 times 0.5, and then times 100%. I got 3.125%, which is 3.13%. Okay, this is the same answer as the one that I used the AT over AO. You get same answer. Okay. Now, then what is the percent of the decay remain? Again, we're gonna use 100%, right? How much originally I start minus how much I have left over. in percent, then I will find how much percent is gone, how much percent decay. Okay, so percent decay equals to 100% minus my percent remaining. I'm going to rewrite the formula here again because I know some people did not get that right away. So 100% minus percent remaining. I get this formula from here. This is just simple algebra. Original minus how much left over will be how much you got. Right? So 100% minus 3.13%, and you should get 96.87%. Okay. Now, number 8A, what percent of our 125 has remained if there are 37.5 grams left over? So same idea as number 7, but number 7 you're giving half-life, and here you're giving gram. So in the previous worksheet, I did ask you, you can look up from the graph. I look it up. Because I have 37.5 grams left over, that means the N is 4 half-life. And then once I find the 4 half-life, I punch it into this equation, and I will get 6.25%. But actually, you don't even need to do the math here. Like, you don't even need to do this part, because I can go the other way. I have the AT. Well, AT is my 37.5 gram left over. This is my AT during the time when the time is 240. Okay. So I'm gonna write it. Okay, this is my 80. Okay, this is my 80. Okay, this is my 80. I would say the T is, how about A240? Okay, this is my 80, right? 80 at the time is 240. Okay, so at 240, okay, I got 37.5 grams. Now this A40 is actually AT, right? When the T is 240 days. Okay, this is 80 when the T has 240 days. So that's why I named this 240. Okay, so this is my A amount. So then how can I find the percent remaining? I'm going to use this formula, AT over A0 times 100%. Now this time my AT is this one, A240. And my AO and times 100%. So my A240 is 37.5 grams over my AO. What's my AO? My AO is 600 grams. Okay, so if I punch in calculator, 37.5 divided by 600 times 100%, I will get 6.25%. I will get 6.25%. If I use this method, it's actually the same answer if I'm using an half-life. Okay? Same answer. I get same answer. Okay? And then what's the percent remain at decay will be same idea. My percent decay is 100% minus how many percent that remain, which is right here. I'm using this formula. And so then I will get 100% minus 6.25%, and I will get 93.75%.